Eswaran, a highly respected scientist and educator whose contributions have greatly advanced the fields of organic chemistry, nanotechnology, biotechnology, and material science. Dr. Eswaran's distinguished career includes 44 years of teaching at St. Stephen's College and serving as Principal of Deshbandhu College, where he has left a remarkable legacy in academia and research. He has also served as the head of the chemistry department and dean of academia at St. Stephen's College. Dr. Eswaran has held several prestigious roles, including Adjunct Professor Honorary at Deakin University, Australia, at the TERI-Deakin Nano Biotechnology Centre, and Emeritus Scientist at the Regional Centre for Biotechnology, UNESCO DBT, and CSIR. He has served as Emeritus Professor at the Academy of Scientific and Innovative Research, AcSIR, and as Professor Honorary at the Amity Institute of Environmental Toxicology, Safety and Management. Dr. Eswaran has made significant contributions through his postdoctoral work at esteemed institutions such as the Max Planck Institute for Biochemistry in Munich, University of Heidelberg, University of Karlsruhe, University of Göttingen, and Fleur Lab of Biotechnology in the Netherlands. His research has also taken him to Ohio State University and Brown University in the USA. His exemplary teaching has been recognized with numerous awards, including the Dr. Abdul Kalam Lifetime Achievement Award, the Indian National Science Academy Teacher Award, and the Delhi University Distinguished Teacher Award. His postdoctoral research has been supported by the German Academic Exchange University Grants Commission, Fellowship, and the Atomic Energy Commission Postgraduate Scholarship. His groundbreaking work spans a wide array of fields, including the discovery of the molecule Viswamayene, the development of long-lived transients, and nitrene-carbene conversion. He has also made notable strides in nanotechnology, notably isolating conducting oligoacetylines from landfill waste for application in electronics and medicine, and identifying a new nanochiral amino acid, Walpahari acid. His innovative spirit extends to industrial applications, including the development of patented photoresist for microlithography using cashew nut shell liquid in collaboration with DRDO. This lecture series, guided by Dr. Eswaran, promises to be a dynamic exploration of science beyond textbooks, where creativity, philosophical perspectives, and real-world applications merge. We are privileged to learn from Dr. Eswaran's vast knowledge and look forward to an engaging series. Please join me in warmly welcoming Dr. S.V. Eswaran. Now, I would like to invite Dr. Eswaran to deliver today's lecture on the topic Viswamayene and long-lived transients.
Thank you. I'm Ria Selvi. Thank you for a kind introduction. I'm at home. This is my home. St. Stephen's College is my home. I request you and your other friends to now put up my PowerPoint presentation, if it can be done. Who is going to upload it? Is it Pradyusha?
Yes, sir, I am going to do it.
Yes. Let me start in the meantime. It's a delightful homecoming. I was in Delhi on Saturday, suddenly for a day, and for some very, urgent reason, but didn't have time to come to college. But we have enjoyed this long association with college, a very well-known, if not the best college of the country. So can you put it on slideshow?
Yes, sir.
And also, can we enlarge it? Yes, there we are. Here I'm enlarging it. Yes. So the topic of today's talk is Viswamayene and long-lived transients. The fact is that this new name has been coined in St. Stephen's College. Of course, it's taken many, many years to do so. But we will get into the details of this talk shortly. I will hopefully not talk too long so that I hope there'll be enough time for questions. But before that, I want to make it very clear, we want that the audience be with me. So I must speak in a manner that even though all the topics are research-based topics, still I should be understood and the young people in the audience will enjoy it and take it as an encouragement. The next slide. See, there are next slide, please. The fundamental questions that are there before all of us are, what is the purpose of a college? Can we have the next slide? Or shall I run it? Who will run it?
So I'm running it. Just a second, sir.
Yes. So, fundamental question arises, what is the purpose of a college? And how is St. Stephen's different, for that matter, from other colleges? I hope there are students not only from our college and faculty from other colleges listening to me. St. Stephen's, as I wrote this morning, the slide that he's going to put up, is a very special institution where the senior members and the junior members live together on the same campus, learning from each other, and be engaged in fellowship in the broadest sense of the term. We at St. Stephen's have never thought that we are a research institution, strictly speaking. We are an undergraduate teaching institution, and therefore, I think there must be a difference between the way other institutions function in the country. Namely, the college, as I said, emphasizes fellowship between the junior and the senior members. Therefore, the education in St. Stephen's College is a round-the-clock affair, round the 24-hour cycle. And we wish that outside the classroom, the learning process continues in an uninterrupted fashion. This ensured that college remained #1 college in the country for a very long number of years. And there are many eminent old students and alumni on which I think we have to give separate lectures, so I'm not intending to do so just now. But remember, we are different from a research institution. The research institutions are highly funded, like the AcSIRs, IITs, or other labs, like the national labs. But there is a statement I heard in 1981 in person, in the centenary year of the college. Go back to that, please. Centenary year. Dr. V.K. R.V. Rao was once the Vice Chancellor of Delhi University and subsequently Education Minister in the Union government. He said, UGC should learn from the 100-year-old successful experiment at St. Stephen's College. Whatever he meant, you can discuss with me. You can discuss anything at any time during this talk. But also I'd have to keep started at about 6:15, I presume, look at the clock. In this series of lectures, we wish to encourage both young students and the faculty, not only from our college, but also from other colleges in the country and abroad, to enjoy science, doing science, and excelling in the same. The topics covered are from my research papers published by me over the last decade, post my retirement in 2012 from St. Stephen's College. It was one of the greatest miracles that in the last decade or more, I have been able to continue to do my research work. It is emphasized that the major occupation of a teacher is to engage in good teaching and being available to the students round the clock. The classes of undergraduate students should be, or undergraduate college, the nature should be very different from that of the, as I said, national labs and so on. Being role models and engaging in fellowship with one another, yet ensuring excellence should be the guiding spirit, is my first statement. Let us not misunderstand that we are a research institution. We are an undergraduate teaching college with our special features. And I think this must be kept in mind. Next slide. You see, what are we going to discuss today? What are the questions raised? What is Viswamayene? If somebody in the audience knows more than me, he or she is welcome to answer the questions at any stage of the talk. What are reactive intermediates? What is the lifespan of such intermediates? What is a nitrine? What is the 100+ years old reaction called the Curtius reaction? Is it taught in undergraduate classrooms? What are, shall I say, the singlet and triplet nitrines? Which is generally more stable? Which one is generally more stable? What are carbenes? Is this a chapter in the second year or postgraduate classes? What is a Simmons-Smith reagent? I shall not explain, you read in your textbooks. Can nitrines get converted into carbenes? Can these reactive intermediates undergo cycloperambulation? We do pradakshina in a temple around the Sanctum Sanctorum. What is ring expansion? What is ring extrusion? Why in our case, the singlet triplet flip did not occur? And what is the significance of this observation? How does one measure the lifespan of such transient? The answer lies in what is called today as ultra-fast spectroscopy. I hope all of you could hear me, so we can go to the next point. Pratyuksha is allowed to do so when he thinks I have finished the slide. See, we are going to discuss a very highly technical topic which is taught in the second year onwards, presumably not at school level. PN in the title stands for phenylnitrene. And the reactions of phenylnitrene are very well established. There is a very important role substituents play, which some people have described as mysterious role. In this most enigmatic reaction of aryl nitrines or aryl azides. Incidentally, azides chemistry won the Nobel Prize 2022 under the garb of click reaction. Click reaction was initially discovered by Professor Rolf Huisgen in Munich in the 60s, but took a long time to do the reaction. He is called the father of 1,3-dipolar cycloaddition reactions. What is shown in this particular slide, I must say that in this particular slide, you see a phenyl azide losing nitrogen under either photolysis or thermolysis to give a reactive intermediate, which can be a nitrine, either a singlet or a triplet. And then it ring expands to a 7-membered ring. You can see the 7-membered ring has 2 double bonds, one after the other, something like an allene. These are called heterocumulines. On the other hand, the singlet nitrine can flip to a triplet nitrine, which is generally more stable, which can eventually lead to the formation of azo compounds, which are generally colored if there are more substituents. Have I already lost my audience? One of you should answer me, if you can.
No, sir.
No, sir.
Stephen Hawking, when he wrote his famous book, the editor told him, you have one mathematical equation in the book. If you add one more, your sales will drop by 50%. By the end of this talk, I want my flock with me and not to lose any of you. So please, if you don't understand me, raise your hand or tell the administrator, I have a question, and put the question so that I will stop my talk. As we go to the next slide, around this year, 1973, 1980, I was reading a lot on these areas. The work started in 1976 in my first trip to Germany as a Dart scholar, the Deutsche Akademischen Austauschdienst, a German academic exchange research fellowship. I could work at either Munich with Huisken, or I decided to work with the Biochemistry Institute called the Max Planck Institute for Biochemistry in just outside Munich called Martinsried. It was a village name. Bank, actually did this work. What is this work, if I'm to explain? He took a pentafluorophenylazide, 5 fluorines, on an aromatic ring in which there is an azide on the outside. The azide readily loses nitrogen to form a nitrene. But you see, we are not seeing a 6-membered benzene ring here. We are seeing a 7-membered benzene ring. And the 2 nitrogens which are in the ring expanded azipine ring, as it is called, they are trans to each other. This was done at the University of Manchester Institute of Science and Technology. This was predicted by Hagen and Bailey. Hagen Bailey, a student of Jack Baldwin from Oxford. Abramovich had also worked on it. And the question is, it was suggested that in pentafluorophenylazide, the phenylnitrene, pentafluorophenylnitrene, remains in the singlet state and does not flip. That means it has a long lifespan. The third or last part of this talk, you will see in our case, what is the lifespan of such a nitrene. What is the importance of the lifespan? The longer the lifespan, you'll understand these are in picoseconds, not in seconds or milliseconds. These are in picoseconds. If the lifespan is long, the chances of intermolecular reactions become very high. That's what you are seeing in this slide. That one aromatic ring expanded, the nitrogen went in, and somehow, some way, mysteriously, 2 such units joined together. Am I in a position to say you've understood me? Can some student repeat it? Yes. Unmute somebody.
Yes, sir.
Understood, sir.
Wonderful.
Yes, sir.
I think such bright students, I think it's a delight to have such bright students. Fair enough. So,
Sir,
yeah.
sir, I have one question.
Who is this?
Sir, what
Identify yourself.
Can you hear me, sir?
Yeah, very nicely. Please.
Yes. Sir, what is the application of fluoro this means this chemical? What is the basic application in the chemical industries?
What is the use of a newborn baby? What is the use of a newborn baby? It can only cry. It can drink milk from the mother. It cannot build any instruments or infrastructure. I think it's a good idea to take the baby and the bathtub and throw it out of the window. Sorry for that answer. But I think your question is good. Should one find out an application all the time? Yes, if there's an industrial use, very good. There is no industrial use. You see, actually, on my left, I see the Western Ghats just outside my window. Thick clouds. The sun is just set with a silver lining. If I sit there, I can write a poetry. Of what use is that poetry? It doesn't produce money. It produces joy, creativity. Yes, many fluorinated compounds, which are very difficult to make, because the moment you fluorinate an aromatic ring like benzene, there is an explosion. One day I was working in Germany, and I was working with hydrogen fluoride and pyridine. They all said, thank you, the whole lab is yours. We are going on picnic, we don't want to be here. Many of them, these fluorinated compounds, aromatic compounds, are used in making fire retardant dresses. Have I answered your question fair and square? You can make fire retardant dresses.
Sir, I have another question regarding to this.
Yes.
Sir, can I use this compound in petrochemical industries?
1 minute. You know that most of the benzenoid compounds come from the petrochemical industry, whether it's benzene, toluene, xylene. But this one is not from the petrochemical industries. In India, they make fluorine only in Gujarat, one or two places, especially in Gujarat. Fluorine is a very highly toxic chemical. There is one professor working on fluorinated compounds in Jaipur, Rajasthan University. There was one lady working in IASC, Bangalore. You won't find many people working with fluorinated compounds. This comes, the origin is petroleum industry, but it may be used for multifarious purposes, including for developing, shall I say, fire retardant fabrics. Are you satisfied?
Yes, sir. Thank you.
I thought about your name again, please.
Sir, Saptarshi Mukherjee, MTech Nanotechnology.
Oh, wonderful. I don't know. I don't think I taught you, did I? Anyway, good luck. What I say is, be in touch with me. I'm very happy that you have asked two important questions. Next slide. We will have to hurry because otherwise we'll finish only one part of the lecture. The second part may have to be postponed to another day if we go at this stage. See, generally the triplet state is more stable. But in this fluorinated case, the singlet was stable. I knew this, and it's temperature-dependent phenomenon. This is well known. But what is the difference in energy barriers? Why is the triplet not being formed here? Next slide. See, in this diagram is shown the fact that the triplet is formed in this case below minus 150. The substituents ortho to the fluorine are very, very important. And as I said just now in the answer to the question, fluorination of aromatic compounds is not a trivial exercise, very difficult job. Maybe it is accompanied with explosions. The question is, can we do without fluorination? That's where my work will come. The energy barriers in the case of nitrine and the carbines are shown here. And if you can see closely, the energy barrier and the flip between the singlet in the case of nitrines and the carbines. Hey, what are you talking about? You are giving a talk on nitrines. And suddenly, no, we'll come to that later. But you are now talking between singlet and the triplet state. What happens is when there is, fluorine, the barrier to this flip increases to around 8 kilocalories per mole. The calculated. So the flip is not allowed. Summarized. Generally, it's a temperature-dependent phenomenon, but the presence of two ortho-substituted fluorine atoms increase the barrier of conversion between singlet and triplet state. Therefore, the triplet is not formed. Next slide. You see, here again, you see, this is a tetrafluoropyridylazide. The ring is not aromatic benzene ring, it's a pyridine ring. So, again, one ring dimerized, 2 units joined together, but there came out one carbon on either side from the benzene. The nitrogen came into the ring, which was outside, and the carbon came out, something like the Arab and the camel. But the two carbons came out in a certain form, which second year students suggest and learn as carbenes. The two of them join. See the double bond in the middle? Can you see the double bond in the middle? So I had been reading about all these things over the years, the work from Banks and others. I met Sandberg in a conference. I also met Hans Suzuki in Heidelberg, went to his house for dinner in Salford. Scriven wrote a book, and a student of mine went to Princeton, sent me a copy of the book, which cost $99, which looked a huge amount of money for me from Princeton, which was very helpful to me. There is a certain pathway to which I'll make a passing reference called the Kurt-Ventrup pathway. Ventrup is about 96 years old or so in Australia, served as the editor of Australian Journal of Chemistry. I've been in touch with him lately too. What is the summary of this slide? Instead of aromatic benzene ring, you take fluorinated pyridyl azides. Still you see spectacular phenomenon, but not ring expansion, but ring extrusion, where a carbon has come out from the benzene ring, a nitrogen which is outside has come into the ring. A ring extrusion. I said fluorination is very difficult. Next slide. Right? I have used the word cycloperambulation at the beginning of my talk. What I'm showing you here on the left extreme is a phenyl nitrene. Phenyl nitrene undergoes some gymnastics to form two reactive intermediates. One is called benzazidine, the other is a cycloheptatriene carbene, and then the nitrogen comes into the ring and the carbon goes out. That means a nitrene became a carbene. This is discussed under the title Kurt-Ventrup pathway. Yes, I met again P.A. Smith. This is very important. How to continue working on a certain field from 1976, 48 years. You have to meet people in person, talk to them. Nowadays, it's possible through Zoom and such other meetings, but nothing like a personal one-to-one. Met him in Heidelberg again. Next slide. That means 1 minute before we go. The nitrene has become a carbene. These are two separate chapters in organic chemistry in second year in MSc. How can a nitrene become a carbene? But the problem is this nitrogen, hydrogen, carbon, all that we write in chemistry is a language. Actually, we don't see, suppose we were able to see these reactive intermediates. We were able to see the molecules. Would we see a nitrogen N written there or a hydrogen H written there or a carbon? This is a collection of electrons for which chemists have found out a very nice way in their language to be able to, represent them, talk about them amongst each other, understandably. But this is not a correct portrayal. It's an ensemble, a collection of electrons, different electron densities, and so on. But what is cycloperambulation? In the next slide, we will see it. The greatest organic chemist of America, as described by Professor Corey Nobel laureate, Orwell Chapman, actually showed that drawing which you are seeing there. Can you see the drawing? Let me explain the drawing to you, not in detail, because in the next slide, same thing will be repeated. This is a temperature-dependent phenomenon. It is photolysis. The phenyl nitrene is getting converted into heterocoumaline. Then it gets converted into a pyridyl carbene. Then again, ring expands, and the pyridyl carbene goes around. This lone pair of electrons goes around the whole ring system as if it's doing a pradakshina. You'll see this in the next slide too. This is called cycloperambulation. In the next slide, we come to the fact that in 2013, computational studies had become very fashionable. Till then, the experimental work dominated. But computation came in. If you see in the slide, here, we are starting
Excuse me,
with...
sir.
Yeah.
Sir, I have
Yeah.
one question.
Yes.
In the computational studies, which you told, sir, here comes a field called bioinformatics or chemoinformatics. Is it
Yeah.
right, sir?
Chem informatics, not chemo. Chem.
Chemoinformatics.
Not chemo. Chem informatics.
Okay. Okay.
Chalo, go ahead. Ha.
Sir,
What is
basically,
your...
can I tell, sir? Can you hear my
Yeah,
voice?
please. Or what I suggest is, 1 minute. Though I offered this, to end this lecture, we have to do a lot of work. So you must be very sharp with your question. Don't ramble. Go ahead.
Sir, during this chemoinformatics, chemoinformatics, what is the main perspective of bringing this computational study? What was the main objective?
1 or 2 lines answer. Somebody does not have a laboratory, does not have chemicals, does not have money, but has a computer and a software, he can still do a lot of science at home. Number of people are taking PhDs in computational studies in chemistry, and they are getting positions as lecturers and so on. And their thesis very often does not even have one experiment in the laboratory. So let us go on. So I will come back to your thought towards the end. It's a very good question. Can chemists work without a laboratory, without chemicals? Just do work on the computer, nothing wrong. This man showed that in the slide that you see, that slide shows that the nitrine and the carbenes undergo strange types of reactions. And the nitrine is getting converted into carbene through many transition states, many intermediates. Next slide. Professor Platz from Ohio State University, with whom I interacted more than once, wrote to me, you can read on your own. I don't have to read necessarily. And he wrote to me in April 1997, I prefer to receive a reply by email. I did not know what is email. VSNL, then Videsh Sanchar Nigam Limited, told me there is only one place in the entire city of Delhi, in Jhandewala, near Karol Bagh, where there is email available. He told me, a computer, please use the computer, send the email. I said, I don't know how to open the computer. What to draft an email? But I sent somehow and went to Ohio State University. And I published with him eventually in 2012. He wrote, the era of fast spectroscopy has just begun. Before entry into the fast spectroscopy era, photochemistry of phenyl nitrine was truly bewildering and full of conflicting facts. I've also quoted Chapman. I will narrate if my friend will ask this question. What is this holy benzene? What is the story that Orville Chapman narrated in my presence in a talk? Samioka did matrix isolation studies at 2 Kelvin or 4 Kelvin and so on to trap some of these intermediates. Next slide. That means they do exist. They're not hypothetical. Next slide. Professor Platz wrote to me some years ago, some of your recent observations are extraordinary, and thus this observation is unprecedented. He is the father of aryl azide chemistry, especially as a physical chemist. Next slide. In a book by McKillop, he wrote about my work. This has been described as a most unusual reaction involving a series of rather involved rearrangement reactions. The sentence is rather involved. I have not written it. This is written by McKillop, who edited this book, Advanced Problems in Organic Reaction Mechanisms. We are trying to see things which we can't. We are trying to study things which are very transient and then talk about it confidently. Next slide. Yeah. This slide is shown. I don't want you to read it. Somebody has written a title very nicely. This subject is still flourishing. Huh? With this paper, can somebody read which year was this paper published?
Yes,
Somebody
sir.
could not. And which
Yes, sir.
year was this paper published?
So I think they are published in 2023 and 2024. Very recent
Next
papers.
slide is 24. Yes. See, look, that means this is coming from University of California, the next paper, I presume. Next slide. Thank you, Manar Bhava. No, go back. Both these papers are shown there, and these are published in 2023 in very respected journals, and Journal of Physical Chemistry. I have a paper with plots there, and another one is, I think, Royal Society, I presume, 2024, Synthesis and Reactions of a Cobalt-Supported Singlet Nitrine. I have finished the first part of my talk, and we will only cover 2 parts today, and maybe we'll continue on the next occasion because I don't want to overload you. Other than my friend, is there some comment somebody wants before we go to the next slide? Any faculty? One or the other who is
Sir,
very
I
much
have one
interested?
question.
Who is this?
Sir, Saptarshi.
You will have to wait because I want some other input. We'll hear you at the end again, and we can continue a one-to-one as long as you want into the midnight. Anybody else? Saptarshi, put your question. Don't expect the answer just now. Go ahead.
Sir, my question is, what is the future objective of bringing the quantum computing?
Aha. Yes. Maybe here there are 2 words written somewhere. I will show you. On top of this, do you see there is a circle? Can you read? Spintronics and quantum computing.
Yes.
Manur, would you like to make a sentence or 2 on this very quickly? Let's
Yes,
be
very
business-like
quickly.
now.
Let's just understand what spintronics means. It means that using
You're
the
doing PhD
spin.
with me along with TERI-Deakin University, Australian University. Go ahead.
So
He's a student of physics.
So we know the conventional electronics where we know the flow of charge means current. And here using the spin states, we can manipulate the electrical currents. So that's the basic of it. And the different singlet and triplet states can represent the 0 and 1. And that is what is used in quantum computing. This is the short answer. We can discuss this later.
Thank you. Yes, at the end we can discuss and you can come into the discussion, Manurubha. But what is important? What did we discuss in the last half an hour? I said the world knew of one example with a dangerous fluorination of an aromatic ring where very special long-lived singlet nitrine led to very interesting observations, either in terms of ring expansion or ring extrusion. This is unbelievable. The second example, I discovered it in St. Stephen's College. That takes us to the second part of our talk. Go ahead. Viswamayene. This name was given by me in 2013, though I've been working on this area for many, many years. All of you can see the NMR, H1 NMR spectrum of this compound. A new compound, nobody else has this in the world anywhere, even today. If you see, there is a cluster of peaks. If you count the number of peaks and the values for those peaks, you will see that these are 8 in number, from 3.33, 3.64, 3.72, 3.80, 3.85, 3.90, 4.00, 4.01. This is an experimental observation that was put up before me. Our compound had 4 methoxys, that is 2 methoxys and 2 methoxycarbonyls. The number should be 4. And they should be identical in a symmetrical compound. So there should have been either 2 peaks or 4 peaks. Here there are 8. What does it tell you? What you saw in the first part of the talk. The nitrine or whatever that species was had undergone dimerization. The nitrine, in our case, had a molecular weight or the molecular formula added to the weight of 267 AMU. Have you understood me? This is the Viswamayene molecule we are talking about now. I'm not going to show you the structure. The observation that came to me in the late 80s into the 90s There are 8 peaks, all are different from each other, though very similar, but they're not identical. That means there must be an asymmetrical structure. Do you understand me? This is the crux of my work. Next slide. We repeated the mass spectrum in 5 different laboratories, including the Max Planck Institute for Biochemistry, Martins Reed. If you can see, the highest peak in this mass spectrum is 534 units. That means 534 divided by 2 is 267. That is 2 units of the nitrine. Azide had 28 more value, 267 plus 28, lost nitrogen, so it became 267, became a reactive intermediate, dimerized. 267 and 267 gave me 534. Confirmed. Next slide. Hold on. Yeah, that is Viswamayene. Born in St. Stephen's College. I don't know the year, but the name was given by me in 2013 when I put the name in Banaras Hindu University's CRSI symposium. The diagram on the left is provided by Professor M.A. Vishwamitra, Physics Department, IISc Bangalore, and Dean Academics, IISc Bangalore, student of Dorothy Crawford Hodgkin, Nobel laureate, who said Vishwamitra has green fingers. Anything he touches, he crystallizes. He did my crystallization as well, my compounds crystallization. He didn't crystallize me. Can you see clearly in the drawing done by me with my own hand, the color and so on, and then photographed? There is a 7-membered ring. Can you see a 7-membered ring? There is a 6-membered ring. Believe me, the 7-membered ring is an azipine. The 6-membered ring is no longer an aromatic compound or ring. It is a pyridine ring. And there is a carbon in between the 2 rings. That means 1 carbon from the right-hand side came out of the ring. So there's a ring extrusion. On the left-hand side, there is ring expansion. So ours is the first example of a Viswamayene formation, is the first example of a concomitant ring expansion and ring extrusion. Both have happened in our case. How? For young students and faculty, concentrate on your work. Do not worry about lack of space, money, manpower, instruments. What you need is being tough, being sincere, and being creative. These come at a price. Sometimes it's not easy to be a teacher in an undergraduate college when others have much more funds, others have all instruments, but it makes you tough. And many of my undergraduate students, I will tell you in one of the later lectures, have contributed in the experimental work even at late in the night or through the day. That is Viswamayene. It's a big systematic name. One azipine ring or azipinylidene ring and a pyridyl carbene have joined together. Are you saying there was a nitrine and there was a carbene? I proposed this in the 1990s that there is a nitrine and there is a carbene in my species. The nitrine flips to a carbene, but the singlet nitrine, from which the 7-membered ring expansion took place, does not flip to a triplet. Next slide. This paper of ours, can you see, somebody can read the title, or this young friend who's MTech in nanoscience will read the title, 2013 Journal of Organic Chemistry. Can you read the title? Anybody can read the title. Quick, we have to finish this talk also.
Concomitant nitrine and carbene insertion accompanying ring expansion, spectroscopic X-ray and computational studies.
Who is speaking?
So this is me, Aryan.
Can you explain this title from what I have explained the last 30-40 minutes?
Okay, so Okay, so like from what you have explained, like here's nitrate and carbon, like ring extrusion and then ring expansion, both are taking place simultaneously in the same molecule.
How did we find out? By spectroscopy, by X-ray, and computational
Okay.
studies.
Yeah.
And we collaborated with Ohio State University. This is published in Journal of Organic Chemistry. Is Mr. Dr. Sujit Thakur in the audience? Hello? Can you find out the impact factor of JOC, Journal of Organic Chemistry today?
Hello, ji sir. Hello.
What is the impact factor of JOC today?
I think near about 3.
3. It is a highly respected journal. Can you see in the abstract the word Viswamayene written? I hope all of you noticed the word Viswamayene. They did not cut the name. There is a footnote also in the references. So Viswamayene is published in 2014, January, Journal of Journal of Organic Chemistry, USA. Next slide. Thank you for your explanation, young man. This is the result of computational studies, which was done by different groups, especially the group from Christopher Haddad in physical chemist and a computational chemist in Ohio State University. I have never met him. Summary of the slide. The nitrine compared to the carbene at the extreme right, the carbene is more stable than the nitrine, but to flip from the nitrine to the carbene, it has to undergo lots of gymnastics. Lots of gymnastics. All these energy values are calculated by computational methods. And what I said in 1990 was published in 2014. Yes, the carbene is more stable and both the products are formed. Next slide. This is one particular set of acids or saturated. You know, there are double bonds. Can you go back to the Viswamayene structure? X-ray. There are double bonds in the 7-membered rings. There are double bonds in the pyridine ring. The pyridine ring double bonds will be difficult to hydrogenate, but the 7-membered olefinic double bonds in the acipin 7-membered ring can be hydrogenated. Can we make, next slide, we go back to the table. Can we make saturated analogues of all these compounds? You will see in many of them, the double bond in the 7-membered ring has disappeared. That means we have hydrogenated it by using hydrogen and palladium charcoal. This is computational studies done by our students. The molecular weight, dipole moment, everything is given. And the prediction, what could be the activity of these molecules, orally absorption in oral manner, etc., are all calculated by computational methods. These are saturated analogues of Viswamayene. Who did this work? Meenal Jain, third-year student of St. Stephen's College, said, I want to work with you. She came to my lab in Regional Center for Biotechnology in Faridabad. We gave her a software called Schrodinger software. For a month she worked. She is a PhD student somewhere. Where, Sujit, where is she a PhD student? In which university?
Maryland, sir. Maryland.
University of Maryland.
Maryland University.
Maybe we will publish.
Maryland University.
Very good, very good. Thank you. So we may publish this work with her. I have not taught her in St. Stephen's College, but she was very keen to meet me. Next slide. I think that was 2017. The last part of this talk will be very quickly go through, and then I think we would just be about within the time. I hope the organizers think this is okay. There are a number of nitrines, which including the kind that we were talking about, whose lifespans are known. One of them is 32 nanoseconds. One is 250 nanoseconds, and so on. Next slide. 120. This is an observation I made in Ohio State University in 1997. When you see two peaks on the left side of the drawings, you know the presence of the singlet and the triplet nitrine. This is by what is called nanosecond flash photolysis, fast flash photolysis, two peaks in the left-hand side top diagram. The big diagram, which is rectangular, you have only one peak, broad peak. That means the singlet did not flip. Next slide shows the actual observation I made in 1997. There's a broad peak, but there are two separate humps. This is with my what is called azido-metahemipinate, a molecule precursor I made in Germany, 1984. Subsequently, we made this and converted into Viswamayene. Yes, 1997, I suggested that the singlet nitrine is long-lived. Go on. But this paper was published jointly with Professor Matthew Platz as the senior author, Christopher Haddad, the computational chemist, myself, and two students from their laboratory. This was published. My young friend who introduced me told you all that I have done a lot of organic chemistry. Surprisingly, this paper is published in 2012, the Journal of Physical Chemistry, when I was just going to retire. What a gift. What a gift. St. Stephen's College blessed me and continues to do so. I'm so grateful to you for this chance that I give you a series of talks. Next slide. This was done by transient ultraviolet visible and transient IR spectral studies, and they were able to show that the lifespan of the reactive species, the singlet nitrine in my case, is around 700 picoseconds. Can you believe it? This is published in Journal of Physical Chemistry 2012. Read the entire paper, but you have to travel abroad. If you have money, go with the money. If you don't, I'm not asking you to travel by other means. Somebody should finance you. Go around the world, not to conquer, but to do science. I have shown that courage all these years. Whether I have a test tube or not, I'll continue to work. Whether the lab size is very small or large, both Sujit and Manur Bhav are giving me the good news that very soon we may be shifting our lab from NSIC, National Small Industry Corporation, Maidan, to FITT, IIT Delhi. All of you are welcome to come to our lab. What is the lifespan of my singlet nitrine? 700 picoseconds. So what are you talking? Is it long-lived? Yes, by the standards of these reactive intermediates, it's a very long-lived species. Go ahead. Next slide. The computation was done in this particular case also. If you can see, the singlet nitrine has more energy content than the carbene. That means the carbene is again more stable. But the nitrine has got converted into the carbene through a lot of transition states, so-called intermediates, and then eventually come to the carbene. This is purely based on computation studies. But all the suggested structures were given by me. They put it in their software, gave me the result. It's published now in Journal of Physical Chemistry 2012. Next slide. I think I may not want to go into this, but many years ago, Professor Platz wrote to me in another case of a very similar azide called azido-metamaconine. By the way, Ryan McCullough has studied your azide by laser flash photolysis. We see an intermediate 10 nanoseconds formation of a species which then does not decay. It is strange. Have you done any product studies with this azide? This experiment was done by me. In the next slide, in 2006. This is a thermolysis product. It's a different pathway. Next slide. See, here, 9.02, there was a species with molecular weight 248, which I did the experiment. One day I stayed in the laboratory by GCMS photolysis of azido-metamaconine. This 248 is nothing but an adduct nitrine insertion, which we readily discuss in college in the second year and third year. the nitrine inserted into the solvent called acetonitrile, CH3CN. So it became NHCH2CN. Such an observation has never been made in the Ohio State University. Next slide. We repeated this in 2023 in our NSIC lab. We have now worked out, it took me more than a year, 2 structures which are formed together. Very unusual. The nitrine insertion product into the acetonitrile actually dimerized in a very special manner, where a 7-membered ring was formed. The other case, the so-called, somebody was ringing me up, nitrine, that adduct, both of them dimerized, giving rise to what we have now proposed, a 1,2-diazine. This diazine is called at the top ring, 6-membered ring, is a pyridazine ring. The biological activities of these are going to be evaluated. Computational studies have been done with this. I must stop with this. One of them is a molecular weight 500. The other has molecular weight 494. They are formed simultaneously. 6 hydrogens less in the structure on the left-hand side, 6 hydrogens more on the right-hand side. This is done photolysis at 266 nanometer in a handheld laboratory UV lamp, which is shown on top. This can be made in kilogram quantities, but we don't make azides in large amounts. These are very new results, unpublished. Come and join us. Is there a slide following this? Numerous areas of applications of these concepts. Numerous areas. From these results of these nitrines, you can go to nanomedicine and targeted drug delivery, molecular electronics, quantum computing, photonic devices, solar cells, photodynamic therapy, bioconjugation and cross-linking, tissue engineering, eco-friendly catalysis, molecular robotics. Some of these applications will be highlighted by me in the next few lectures. I don't think there is a slide following this. Yes, I have kept my talk to within less than 1 hour, as I promised. I have taken questions from my young friend who was persistent, but remembering that I should finish the talk within 1 hour, I preferred to make sure that I do not ramble. So I gave him the answers. Yes, they were crisp. I hope this talk would end with even more exciting questions. What do I want to say to young people and to my colleagues when my former students continue to work? St. Stephen's College is an undergraduate college of great repute. We must teach well in the classroom. We must continue to excel in science, but we should be available for our students round the clock. For science, and for any other personal reasons that they wish to come and discuss. Staff members living on the campus kept an open door policy. I don't want to talk about length, and students could approach them even at midnight. Let me just conclude this with just one example. Professor Muhammad Amin, who had worked at Cornell University, taught history so wonderfully. Even Shashi Tharoor does not forget him. Shashi Tharoor said the other day that 125-year-old ceremony, when we were celebrating 125th year of St. Stephen's College, he said, "Kya hai?" You know, he taught us, nahi padhaunga, nahi, suno. I taught in the history class, main noore jahan hu, main noore jahan hu. Ya galt kya padhaya maine? Shashi Tharoor said, should I mention this? I do not know. He that followeth me shall not walk in darkness. Main noor is dunya, the world. Jahan is dunya. Noor is that light. So I only translated that, nothing else. And Shashi Tharoor, with this very wonderful command on his English language, with very new words, which I think many of us have never heard, spoke this in the 125th year of celebrations of St. Stephen's College. I mentioned Orville Chapman. One student in the classroom got up and said, "Sir, what? You blast, you talk so many things which we do not even understand. What is its use? You produce no money. How am I going to be impressed if you cannot produce money? Immediately, Orwell Chapman took study leave for 3 years, went to the industry, and he converted ethyl benzene into paraxylene. Those of you know, paraxylene goes into the making of terylene and so on. Spends money, he got a patent, came back to the same post again in the same university and faced the group of students with joy because he had produced money. One of you will ask me, have you produced money? I said, hold on, wait for a little while, little more while. We'll generate tons and tons of money. That's what will impress you. But one of you asked me, what is its use? I said, newborn baby, what's its use? Just to counter the question. But I know the newborn baby can be a Newton or a Galilei or an Einstein. Impose no restrictions on the young child. Give the child all the possibilities of growth. Don't overprotect. St. Stephen's College, there is no spoon feeding. We are a teaching institution where we are available to be together and learn from each other and show the young people directions which they conquer far beyond you. Have I spoken for too long? I think I have been speaking for less than 1 hour. 7:18 or so, 7:15 I started. So 56 minutes I've gone on at this age. I'm so delighted. If there are any comments, if there are any questions, I'd be very happy to take them now. And also you can take my contact details from the organizers. Continue to talk to me through the day, through the night. As a Stephanian, I'm available for you and for fellowship so that we support each other. Thank you so much.
Sir, I have some questions.
Yes.
Sir, in the 2024 technology, right now we are in 2024, there are some promising applications which you showed. One is
Yes.
quantum computing.
Yes.
Then there is some important technologies other than quantum computing, that is the nano electronics.
Yes.
The submersion of electrical engineering and nanotechnology.
Yes.
After 5 years, we are going to see that there is a tremendous improvement in the nanotechnology industry, because these 5 factors, one is quantum computing, one is nanorobotics, another is the microbial nanotechnology, and another is the molecular electronics, which you showed. These are one of the best application, not only for research but also in the upcoming industries. Because, sir, nano
Now, 1 minute.
technology.
You are making 1 minute, my young friend. You are giving a
Yes,
talk.
sir.
We will invite you for
Yes,
another
sir.
talk. But put some sharp
sir.
questions and comments.
Yes, sir. My question is, what is the future perspective of nanotechnology in the field of electronics?
In St. Stephen's College, in 1991, came B.L. Feringa from the University of Groningen, Netherlands. I even took him to the house of a colleague of mine who was going to die of cancer. It was a very terminal stage. Professor Feringa and me walked to his house. The man was very happy that a professor from Netherlands was visiting him. He died a few months later, the colleague. Professor Feringa wrote a book, Molecular Switches. He made a car, a motor car, which was of nano size. If you have a small nano car or a nano motor, you can drive it through the arteries and veins and remove clogs, deliver drugs. He became a Nobel laureate. I did not contact him, could not meet him. B.L. Feringa. That was 2011, 2012. But today, as my young friend says, 5 years from today, my students, Manurbhav Arya, PhD student, physics, Dr. Sujit Thakur, already finished his PhD, are actually this month end traveling to IIT Mandi to do nanolithography and make nano devices. Wish us good luck. My young friend, I congratulate you for being the most. If you were in my class in front of me, I'll throw a chocolate eclairs to you or a packet of chocolates, whichever you like. But since we are 2,000 kilometers separated, I cannot throw a chocolate or a chocolate eclairs to you for your questions. He says 5 years from today, it will be so wonderful. I hope in the next few lectures, somewhere you'll know that we have nanomaterials which are so magical, which are curing so many diseases. You read my article in the Current Science 2016, which is being cited highly. So what you say, I agree. But B.L. Feringa came in 2011, wrote a book, Molecular Switches. Get the book and read it. But it's 2024, as you are emphasizing rightly. 2011 to 2024, such spectacular changes have happened, combined with something which is also threatening partly, artificial intelligence. I think even the sky is not the limit. Because in my childhood, I thought sky is the limit. But I understand there is nothing called the sky. It's only a mirage, a kind of an illusion. We go through the sky and go far away in outer space. Therefore, I agree with you. The future is very bright. You are an MTech, nanoscience, which I was at the same time teaching the MTech in Delhi University on, technology and process technology and synthetic methodologies. The nanotechnology course had just started at that time. I'm very happy to hear you and your questions. And I say, come and join us, yaar. हमारा लैब खुल रहा है, नया लैब खुल रहा है IIT दिल्ली में. आइए ना, हाथ बटाइए ना. तो डॉक्टर ईश्वर लैब में बैठे रहेंगे क्या? No, I will be on the Zoom. I will be on WhatsApp video, and I, whenever necessary, come to Delhi and to St. Stephen's College, but not in the winter months, hopefully. Organizers, it is exactly 58 minutes or 1 hour since I started. If you think you have the time, you can ask the audience.
I have another question. Excuse me, sir, I have another question.
सुनो, मेरा नंबर ले लो, ऑर्गेनाइजर से मेरा ईमेल ले लो, मेरा व्हाट्सएप ले लो, 4 घंटे मेरे साथ बात करो. आज मैं डिनर लेके आऊंगा 8:30. I'm prepared to talk to you because I'm also doing simultaneously more work. The organizers, do you have more time for questions? आप पूछो यार, जल्दी से पूछो अपन क्वेश्चन, जरूर पूछो.
Sir, what is the use of nanotechnology in space?
What went wrong with this? The lady who's trapped in space till to February 25. What went wrong? Tell me.
Sir, Sunita Williams started to work on this project. Means
what went wrong? Come to the question. What went wrong this time?
Sir, I think the propulsion, the hydrogen helium gas. The hydrogen helium gas.
There was a leak.
Yes.
So why did this leak happen? In space, how do you repair that leak? That's the problem. And if there was a nano device, which is not a human thing, it's no life, it will not die in outer space without nitrogen or oxygen and so on. It can go and repair it in no time. And that too controlled by artificial intelligence. It is almost a science fiction that I'm narrating. But the lady is trapped in outer space till 2025 February. Hopefully she'll come back. Innumerable uses.
Sir, one thing, the problem is that we need to send nanorobots. Because these nanorobots, without nanorobots, it becomes very much difficult for the astronauts, those who are in space. So this
हमारे दोस्त का नाम दोबारा बताओ यार. इसको थोड़ा तालियां तो बजा दो. I know all the mics are switched off. Very good. Good comments. The organizers, do you have any other questions or any other comments before we close?
Sir, I have one more question. I'll be happy to ask if the organizers allow.
And you ask the organizers, please. I have no objection. I am at home.
Okay.
Who is this?
I am in the second. Arent speaking.
हाँ, पूरा नाम बताइए.
Arent Thakur.
हाँ, बोलिए. जरूर बोलिए।
Okay, sir. So I'm in second year of my UG.
आपके
So
ऊपर
I don't
गाइड
know
नहीं
much.
है। हाँ
Huh. So I'm in like my second year of UG, and I've been trying to work on project sideways. Like I've been just reading research papers, and my question is, does like your work in Viswamayene, does flash nano precipitation, would that like what's the future of it? Like I've been very interested in this technology lately.
दोबारा उसको रिपीट करिए, प्लीज रिपीट योर क्वेश्चन।
Flash nano precipitation.
What do you, how do you define flash nano precipitation, and why do you want to do it?
So
We wish you good luck
I've
in
been
your
very
area.
interested. Okay. I'm very interested in the perfumery industry. I don't know why. So like I saw the research paper by I don't know the scientist name. So like they just modified a chemical by like I don't get the it was something related to light and something.
Okay,
I
fair
can
enough,
get
fair
the
enough.
exact
Haan ji,
word.
haan ji.
Yeah. So yeah.
The question is, most of these perfumes in which you are interested come from one major country, France.
Yeah. Yes.
And I don't know what is the size of your toothpaste that you use in the morning. What is the size of the tube? How many grams? How many grams?
I don't know, sir. I've never.
अंदाजा बताओ यार, 10 किलोग्राम का है टूथपेस्ट।
No, sir.
कितना होगा?
More than a pea-sized.
नहीं, not the toothpaste that comes out, the entire tube full of toothpaste.
Okay.
What is the price? What is the weight?
200 grams, maybe.
Okay. How much perfume do you buy? 200 grams?
No, sir. 250 ml. Yeah, 250 ml.
And what you are saying, instead of 2-3 ml for which I have to pay a huge price, can I prepare a nano formulation or a precipitation, and a very small amount keeps you away from foul smell in your body? Why not? One of my students did MSc, then he joined for PhD, he taught in college, but he sells perfumes in Chandni Chowk, his family business. They didn't want him to do PhD on that. They didn't want him to do PhD, but he did all that. And they are into perfume business. But the Indian perfumes do not sell as much as the French perfumes.
Yeah.
French perfumes are very costly. A very small bottle. I wish you that you make a nano bottle of perfumes and sell at a reasonable price. So all these people will be displaced out of the business and the perfume will last for long hours. Good luck to you.
Sure. Thank you.
Next person, if there is any. Shall we bring this meeting to a close?
If we don't have any questions, then we will end the lecture for today. Are there any questions? Okay, thank you everyone for joining. Thank you, sir.
Yeah.
We look forward to your active participation for the lectures of the series. Have a nice day ahead, everyone. Thank you.
Thank you so much. A good dinner time. Mahlzeit, say in Germany, Mahlzeit, eating time. Good luck. Bye.
Thank you very much, sir.
Bye. Very kind. Very kind.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you to all. I don't know of many of you, but thank you all.